lesson, you will be able to derive intuitively the relations among chords, arcs, central angles, and inscribed angles. As we are starting in today's task, I want you to bring out your pen, paper, and self-learning module. Are you ready to learn? It's time for us to explore the concept of circles.
Before we proceed to our discussion, let us first answer the pre-assessment for 60 seconds. Time is up! For better understanding, let us continue learning. Since the invention of the wheel, circles have been extremely important to all humanity. In fact, you probably see circles almost everywhere you turn. But mathematically, what is a circle? A circle is a set of all points in a plane that are of the same distance from a fixed point called the center. Let us try this. What is the name of this circle? Circle A.
You're correct!
Since circles is very important in our daily lives, it is necessary that we give some attention to their properties. But before that, we should be familiar first with some important terms related to circles. The first one is radius. A radius of a circle is a segment whose endpoints are the center of the circle and a point on the circle. The next one is diameter. A diameter is a segment whose endpoints are on the circle and it passes through the center of the circle. It is the longest chord. The third one is the chord. A chord is a segment joining any 2 points on the circle. Next is the central angle. A central angle is an angle formed by any 2 distinct radii of a circle. Another one is an inscribed angle. An inscribed angle is an angle whose vertex lies on the circle and whose sides are chords of the circle. The last one is an arc. An arc is a portion of a circle that consists of 2 endpoints and all the points on the circle between 2 endpoints. There are 3 kinds of arc. First is a semicircle. A semicircle is an arc whose endpoints are the endpoints of a diameter. Next is a minor arc. A minor arc is an arc which is less than a semicircle. And the last one is the major arc. A major arc is an arc which is more than a semicircle. The degree measure of a semicircle is 180 degrees. The degree measure of a minor arc is less than 180 degrees. And the degree measure of the major arc is more than 180 degrees. You can see the different parts of the circle in the illustration given. Let us have an illustrative example. In circle A, segment BD is a diameter. Segment CA is a radius. Angle BAC and angle CAD are central angles. Arc BCD is a semicircle, and its measure is 180 degrees. Arc BC and arc CD are minor arcs. Arc CBD and arc DBC are major arcs. After learning the terms related to circles, let us now discuss the relations among chords, arcs, central angles, and inscribed angles. The first one is the sum of central angles. The sum of the measures of the central angles of a circle with no interior points in common is 360 degrees. Example, measure of angle 1 plus measure of angle 2 plus measure of angle 3 is equal to 360 degrees. Let us have another example. Find the value of x. Since the figure showed that angle F is a right angle, its measure is equal to 90 degrees. If you will add 130 degrees plus 90 degrees, that is equal to 220 degrees. Subtracting the sum to 360 degrees, that is equal to 140 degrees. So that means the value of x is equal to 140 degrees. The sum of the three angles should be 360 degrees. The second one is the degree measure of a minor arc, major arc, and semicircle. The measure of a minor arc is less than 180 degrees and equal to the measure of its related central angle. In the figure, measure of arc AB is equal to the measure of angle ACB equals to x. The measure of a major arc is greater than 180 degrees and equal to 360 degrees minus the measure of the minor arc with the same endpoints. In the figure, measure of arc ADB is equal to 360 degrees minus the measure of arc AB. That is equal to 360 degrees minus x. The measure of a semicircle is 180 degrees. In the figure, measure of arc ADB is equal to 180 degrees. Let's practice. Segment PM is a diameter of circle R. Identify each arc as a major arc, minor arc, or semicircle. Then find its measure. In 2A, arc MQ is a minor arc because it is less than the semicircle. So let us subtract the measure of arc PQ to 180 degrees. 180 degrees minus 115 degrees is equal to 65 degrees. So the measure of arc MQ is equal to 65 degrees. In 2B, arc MNP is a semicircle because it measures exactly 180 degrees. So therefore, the measure of arc MNP is equal to 180 degrees. In 2C, arc MNQ is a major arc because it is greater than the semicircle. So to find the measure of arc MNQ is to add the three minor arcs. PQ is equal to 115 degrees. PN is equal to 90 degrees. NM is equal to 90 degrees. (115 degrees plus 90 degrees plus 90 degrees is equal to 295 degrees. Therefore, the measure of arc MNQ is equal to 295 degrees, which is greater than the semicircle. That's why arc MNQ is a major arc. Another theorem is, in the same circle or incongruent circles, two minor arcs are congruent if and only if their corresponding chords are congruent. Example, arc FG is congruent to arc HJ if and only if segment FG is congruent to segment HJ. We have here a real-life problem. In the embroidery hoop, segment AB is congruent to segment CD, and measure of arc AB is equal to 60 degrees. Find the measure of arc CD. So that means segment AB and segment CD are congruent chords. So the corresponding arcs, arc AB and arc CD, are congruent. So the measure of arc AB is equal to the measure of arc CD, that is equal to 60 degrees. Another theorem related to circle is, in the same circle or incongruent circles, two chords are congruent if and only if they are equidistant from the center. Example, segment FG is congruent to segment JH if and only if LX is equal to LY. Let us have this example. In circle H, PQ is equal to 3x minus 4 and RS is equal to 14. Find the value of x. PQ is congruent to RS. So therefore, you can equate the two chords because they are congruent. Substitute 3x minus 4 in PQ and 14 in RS. 3x minus 4 is equal to 14. Transpose negative 4 to the other side, it will become positive 4. 3x is equal to 14 plus 4. 3x is equal to 18. Divide both sides by 3. So therefore, the value of x is equal to 6. Take note of these concepts. An inscribed angle is an angle whose vertex lies on the circle and whose sides are chords of a circle. The measure of an inscribed angle is half the measure of its intercepted arc. In a circle, if two inscribed angles intercept the same arc or congruent arcs, then the angles are congruent. An angle inscribed in a semicircle is a right angle, and therefore the measure is equal to 90 degrees. If a quadrilateral is inscribed in a circle, then its opposite angles are supplementary. Remember these theorems on circles. The measure of an inscribed angle is half the measure of its intercepted arc. In a circle, if two inscribed angles intercept the same arc or congruent arcs, then the angles are congruent. An angle inscribed in a semicircle is a right angle, and therefore, the measure is equal to 90 degrees. If a quadrilateral is inscribed in a circle, then its opposite angles are supplementary. In a circle or incongruent circle, two minor arcs are congruent if and only if their corresponding chords are congruent. In a circle, if a radius is perpendicular to a chord, then it bisects the chord and its arc. In a circle or incongruent circles, two chords are congruent if and only if they are equidistant from the center. Now let's check your learning regarding our lesson. You have 30 seconds to answer. Now, let's check your answers. In the figure, M is the center of the circle. Determine whether each arc named or described is a major arc, a minor arc, or a semicircle. Write MAA if the arc is a major arc, MIA if it is a minor arc, and S if it is a semicircle. In number 1, arc SAY is MIA. In number 2, RSXR is MIA. Number 3, arc SRT is S. Number 4, arc SYR is MAA. Number 5, arc SRA is MAA. Number 6, arc intercepted by angle SMX is MIA. Number 7, arc or arcs determined by the endpoints of XY is S. In number 8, arc intercepted by angle TMR is MIA. In number 9, arc intercepted by angle YMT is MIA. And the last, number 10, arc intercepted by the vertical angle with angle SMR is MIA. If you get the score 8, 9, or 10,
Great job!
there you have it. We have derived the relations among chords, arcs, central angles, and inscribed angles. For your assignment, answer the post-test in your self-learning module.
Thank you for watching, and I hope you enjoyed learning mathematics despite of this pandemic. Again, this is Teacher Dayan. God bless us all!